Well, thanks very much, Adrian, and welcome everybody. Thank you all for joining us today from wherever you happen to be. Some places you may actually be tomorrow or yesterday or something. We've got people here from all over the world. So I'm very happy to have a chance for Candase and I to do this together. We've both done this presentation for other venues previously, but this is the first time we've done it together. So this is going to be kind of fun for us. And we're going to take turns going back and forth, each presenting a few slides. So you'll have a chance to hear from both of us. So I've been interested for a long time in how software teams can improve the way they develop and manage their requirements. This interest, which I developed decades ago, eventually led to me writing several books on requirements and doing a lot of training and consulting in the area. And as consultants, both Candase and I have had a chance to look over the shoulders of a lot of people, a lot of practicing BAs and other people on teams, and we could observe patterns of approaches that worked well and also those that did not work so well. And so this helps you figure out what are some of the common threads that we can all learn from and all do a better job. So the third edition of my book titled Software Requirements, which I co-authored with Joy Beatty, was nearly 650 pages long. This is a seriously big book. But it turns out that busy business analysts, product owners, product managers might not have the time to read a big book. Although, of course, you can only read the parts you need to. You don't have to read the whole thing. Well, there's a lot of good stuff in that big book, but I realized I could distill down the contents, the dozens of requirements related practices that we talk about there, into a core set of 20 practices that every project team should perform. So Candase and I wrote this much shorter book, Software Requirements Essentials. And you can see this is not a huge book, but it's very concentrated. There's a lot of information in there. One thing that's I think really important here is that these practices apply regardless of the type of product that you're building, regardless of the team's development lifecycle. And today we want to tell you about those core practices that we believe are essential to BA success. Now, as we go along, I suggest you think about the extent to which each of these practices applies to your situation and look for ways that you could apply them to improve your requirements or reduce project risk with these practices. Let me also point out the website for this book at the lower left here, softwarereqs.com. I'll be mentioning that a few times as we go along. There you can read reviews of the book. You can see some videos. I recently launched a video series called The 1 Minute Analyst. Just a couple of hours ago, I posted the latest in that series. And you can also download some useful checklists, templates, and spreadsheet tools that we'll be mentioning as we go along. So in order not to be a distraction here, I am going to turn off my camera and we'll come back at the end so we can talk. But this way you don't have to watch a talking head if you don't want to. So the 20 practices are grouped into 6 categories. First are 5 practices that lay a solid foundation for project success. The other practices are grouped into the 5 subdivisions of requirements engineering. There are 4 core practices on requirements elicitation, followed by 4 more on requirements analysis, another 4 on specification, 1 on validating requirements, and finally 2 critical requirements management practices. Now, of course, these are by no means the only techniques that a skilled BA should have in their toolkit. There are many big books on requirements and business analysis that describe dozens of additional practices. I think there's one that even has more than 100 practices in it now. These are all valuable in various situations, but the 20 that we're going to talk about here today, I believe, are the most important and the most globally applicable. In this short presentation, we're not going to describe every practice in detail. We will show you all the practices in each category, and then we'll drill down into one in each of these categories. Little point of terminology. When we say requirements here, we're referring to whatever kind of objects your project uses to represent information about stakeholder needs and to describe a solution's capabilities and characteristics. There's a lot of kinds of knowledge in this category. We might call them business requirements. Some are use cases, functional and non-functional requirements. You might talk about user stories or features or whatever you use on your projects. So rather than getting wrapped around the axle on terminology, just do a mental translation, if you don't like the word requirements, into whatever you call these kinds of information in your world. It turns out that every project has requirements. As Adrian pointed out at the beginning here, you're all dealing with requirements in one form or another. The requirements might be stated or not. They could be carefully considered or not. They could be documented in some form or not. But a good set of requirements lets you answer some important and universal questions like these. People might want to know, why are we even working on this project? That seems like a good place to start. What are we trying to build? Who are we trying to satisfy? What do we implement first? What do we work on after that? And what do we maybe never get done? And that's okay. How can we tell if the solution we come up with is good enough? And everyone would like to know, how do we tell when we're done? So you might ask yourself, if someone asked you these questions about your project, would you be able to give good answers? I hope so. So there are several actions that you can take early in an initiative to get the information that lets you answer these kinds of questions. That understanding helps lay the foundation for a successful project. It makes sure the team addresses the right problem. It helps align everyone toward common objectives. It makes sure we engage the right participants, and it keeps the team's efforts focused. So I'm going to hand this over to Candase to talk now, and she's going to tell you about those core practices to lay the foundation.
No worries. Thanks, Karl. So when we talk about laying the foundation, those core practices, there are 5 practices we recommend to help all projects lay a solid foundation for success. First, understand the problem before converging on a solution. Organizations launch initiatives to solve a business problem or exploit an opportunity. However, sometimes those problems or opportunities are not explicitly stated or documented. Don't presume that either a presented solution or a presented problem is necessarily correct. Instead, do a little bit of root cause analysis to make sure the problem is well understood and that a proposed solution makes sense. With number 2, defining the business objectives, stakeholders need to understand why this initiative is being launched and its business objectives. We'll talk more about this shortly. When we move to number 3, defining the solution's boundaries, anytime you start a new initiative, you might not know exactly where to draw the line between what the solution should and should not include. An important foundational practice is to establish that what's in, what's out boundary. It's a solution scoping action. And number 4, identify and characterize stakeholders. Every project has individuals or groups who are actively involved in a project, are affected by it, or can influence its decision. You need to cast a large net to identify many potential stakeholders. Then you can decide who can best represent the needs of each stakeholder group and how the team will engage with them. And finally, identify empowered stakeholder decision makers. Every project faces many requirements-related decisions. These include resolving conflicts both within and across user classes, prioritizing requirements, evaluating proposed requirements changes, and many more. It's important to determine who the decision makers will be for these requirements issues, preferably before the group confronts their first significant decision. Each group also needs to choose a decision rule to apply when resolving issues. Now, let's take a deeper dive into practice number 2, defining the business objectives. As we look at defining business objectives, understanding the business problem or opportunity is an essential first step toward product and project success. The next step is then to describe exactly what the project sponsor or other important stakeholders expect the solution to accomplish, the business objectives. Business objectives can be financial or non-financial, internal, like operations, or outward-facing, like products. They can also be strategic or tactical. You also want to define some success metrics, so you can tell if you have achieved, or at least are on the path to achieving, those objectives. Such business-oriented requirements lead to us defining a solution concept that you're confident will satisfy the business objectives, along with the scope and limitations that bound the solution. And all of that ultimately lets the team elicit the detailed requirements that describe the solution's capabilities and characteristics. A clear set of business objectives helps the team to identify its key stakeholders who will work with the BA to understand their needs and to define all the necessary solution functionality. Decision makers can then set the priorities of individual requirements and define the contents of each development increment or product release to align with achieving the most important and most timely business objectives. Business objectives let you determine when the business problem is solved, the need is fulfilled, or the opportunity is exploited. A business objectives model is a valuable tool for a thorough analysis of complex problems in which multiple business problems and business objectives are intertwined. The business objectives model visually links problems to objectives, their associated success metrics, and the resultant solution concept. Let's look at a partial example for a proposed restaurant online ordering system. First, we'll start with our highest level business problem. Revenue from our target market is low. That then leads us to an objective that we'd like to achieve, how we know we've solved the problem. So in this case, we want to increase revenue, monthly revenue, from the target market to $28,000 a month. As we think through then, why are we not achieving this today, and think through the business's situation, we uncover additional problems and corresponding objectives, like perhaps most of our target market will only place orders online, or that they don't come back because they're having a poor experience. Our analysis then leads us to conceive of a solution that would address all of those problems and hopefully achieve our desired business outcomes. Here you can see visually how to tie major specific solution features to those individual business objectives, such as that the online menu will clearly support ordering online. This kind of analysis is much better than thinking of a cool looking solution first and then hoping it will give you the business outcomes you desire. And I'll pass it back over to Karl.
All right, well, that's a really important set of activities that lay the foundation for any project. I mean, I can't imagine any project team that wouldn't find those sorts of activities valuable, whether they're doing software or something else. So the first step in dealing with requirements is to get some. And people often talk about gathering requirements, but I don't like that term very much, and I try not to use it. It's not just a simple collection process. So I think a better term for this activity is requirements elicitation. Certainly, elicitation does include some collection, but it also involves exploring, discovering, and even inventing requirements. Requirements can come from a lot of places. The BA needs to look for requirements from various user representatives and other stakeholders, maybe documentation about business processes or current systems, perhaps competing products if you're out in the commercial marketplace. There are probably some applicable laws and business policies and lots of other opportunities to find important knowledge. So there are many places and ways to look for requirements. The skilled BA has a lot of elicitation techniques in their toolkit. They might conduct interviews or hold facilitated group workshops. You can learn a lot by watching people do their work. Sometimes you'll see things that they wouldn't just tell you if you ask them to describe their work. Surveys and questionnaires are useful, process modeling, and many other methods that you can use, picking up rocks, looking for requirements hiding underneath them. So here are 4 core requirements elicitation practices. You know, I wrote a book about a year and a half ago called Software Development Pearls, which describes 60 lessons I've learned about software development in my sort of lengthy career. I started programming in college in 1970, which I find hard to believe. But somebody asked me not long ago, what's the most important lesson you've learned? And I think this is it. Understand what users need to do with the solution. That was one of our pearls of software development wisdom, and it's certainly one of our core practices that we're going to talk a little bit more about here. All systems react to various kinds of events that trigger some response. There can be business events that launch a use case. You might have signal events like inputs from a switch or a sensor. You could have temporal or time-triggered events, all of which lead to some system behavior. So identifying events and responses is another way to go looking for requirements that might not come out of a usage-oriented discussion. All software systems process data, so you must assess data concepts and their relationships. Data modeling is a powerful technique for this purpose. And besides functionality, for every product, you need to explore quality attributes. These are a category of non-functional requirements. There are often trade-offs between these quality characteristics such that you cannot optimize all of them at once. And so it's important during elicitation to figure out which of these many attributes are most important to product success so designers can make the best trade-off decisions. Suppose you were holding a requirements elicitation discussion with some users, like this new user that we've shown here, about some information system. Well, which of these questions do you think would yield the greatest insights? Should we ask, what do you want? Or maybe, what are your requirements? How about, what do you want the system to do? Or should we ask what features they would like to see in the system? Well, yeah, we could ask all those questions, but I think a better question is to ask, what do you need to do with the solution? That shifts the discussion from a focus on the product to a focus on users and more specifically on usage. People often talk about user-centric design or user-centric requirements, but I think the real word is usage-centric. So that's one of the most important things I've learned. If you focus on features during elicitation, that can lead the team to implement incomplete functionality that doesn't let users do all the things they have to do. Now, the IIBA, has this 3-level model. Sorry, I'm still getting over a cold here a little bit, so please pardon my disgusting sounds. The IIBA talks about, in their 3-level model, business requirements at the top and stakeholder requirements in the middle. But I don't really quite buy that, because as far as I can tell, I think pretty much all requirements come from some stakeholder. So I like to put user requirements in the middle of that 3-level model. And here we're talking specifically about requirements from that subset of stakeholders who will actually use the solution in some way. We want to make sure our user requirements align with achieving the project's business objectives, as Candase discussed. Of course, that implies that you need to define those business objectives first, as we just saw a few minutes ago. Now, people very naturally focus on describing the way the system's going to function when all goes well, sometimes called the happy path. But as well as exploring those normal success scenarios, you also need to consider alternative ways the user might accomplish a task, as well as exceptions that might prevent successful completion. So from this understanding of the user requirements, the BA can identify the necessary functionality that the solution must include to let users get the job done. Also, maybe some of you have had this experience. If you make sure that the specified functionality aligns with known tasks, you're less likely to waste time and effort implementing functionality that seemed like a good idea at the time, but then goes unused. I mean, I've had that happen where people told me, oh, I need this particular capability. So you dutifully build it and nobody uses it, or almost nobody uses it. And you work just as hard trying to get that functionality correct as on the stuff people really do use. So that's pretty frustrating. So 2 commonly used techniques for exploring user requirements are use cases and user stories. Use cases provide a nicely structured way to steer elicitation participants from thinking about product features to focusing on usage. The name of a use case defines the goal a user is trying to accomplish. As an example, maybe somebody who posts article on a publication platform wants to view article statistics. I have about 100 articles on my medium.com account, and I look at the statistics regularly. So that becomes a use case name, view article statistics. Here's a little tip. Whenever an elicitation participant says, I want to do something, or I need to be able to do something, that do something likely is a use case. A rich use case template contains categories that you can use to fully describe the use case. You might have preconditions that must be satisfied before the system can execute the use case, post conditions that are true after successful completion. You'll probably list the steps that take place in a dialogue between the user and the system, describe how to handle things that could go wrong, identify pertinent business rules, and so forth. So the BA can then derive all the necessary functional requirements that the developers must implement to realize the use case. You don't implement business requirements. You don't implement user requirements. You implement little bits of functionality that, if all goes well, let people do what they need to do and help them achieve their business objectives. So this is another thing I learned, is that the tests can fall out of use cases, and that's a really powerful quality aid. We'll come back to talking about tests a little later. User stories are typically employed on agile projects as the primary requirements deliverable. A user story is written according to a pattern that provides a little more information and context than the use case name does. We learn something about the type of user and the motivation or rationale behind the request. So for the same bit of need that we mentioned earlier, viewing article statistics, we would write that in the form of a user story, perhaps like this. As an author, so that's the user class of interest, I want to view the statistics for my articles. That's the core goal. Why? So that I can see which topics my readers enjoy the most. Okay. And there might be another why, which is so I can write more on those topics. Okay. So rather than writing detailed functional requirements, Agile projects typically provide the story details through a set of acceptance criteria the implemented story must satisfy. Requirements and tests are complementary thought processes. They show the same information in different ways. Either is fine. But with both use cases and user stories, I think the core thought is to keep the focus on understanding user goals, not on describing functionality. So let's have Candase tell us a little bit about requirements analysis.
No worries. Once you've elicited some of the requirements, you need to analyze them. But what exactly does it mean to analyze requirements? Analysis kind of sounds like something that just happens through staring at requirements long enough. In reality, though, you can use several techniques to search for specific problems and produce better requirements, and hopefully then better solutions. Analyzing requirements is where a skilled BA really adds value. Analysis is an incremental and iterative process, interwoven with ongoing requirements elicitation, specification, and validation activities. Requirements analysis involves ensuring that the needs of all stakeholders are understood and documented appropriately. The outcome of a successful analysis ensures that a satisfactory solution to meet those needs can be defined, agreed upon, built, and tested. Analysis involves multiple thought processes to confirm completeness, clarity, and correctness. You ask questions to make sure you understand what each requirement is saying. Analysis also involves detailing requirements to an appropriate level. You can compare multiple representations of information to spot errors and fill in any knowledge gaps. And of course, along the way, you continue to confirm and refine your knowledge. Here are the 4 essential requirements analysis practices, and Karl's in my view. First is simply to analyze both individual requirements and sets of requirements. I'll discuss this further in just a moment. Next, drawing visual diagrams or models of requirements is an especially powerful technique. I've been a fan of requirements modeling for many years. It is core to our methodology here at Argonne Digital. Additionally, in addition to models, people often create prototypes, which could be possible or preliminary or even partial implementations to better understand the problem and to refine and validate requirements for some part of the solution. And finally, since no team can implement all of its requirements simultaneously, they must prioritize them to make sure the team delivers the most important capabilities in the right sequence to maximize the delivered value. As we analyze individual requirements, here are the major aspects of analyzing them that we should consider. We should be able to trace each requirement or user story back to its origin. Additionally, if anyone asks why a particular requirement is present, the BA should have a compelling answer, the rationale. Another aspect of analysis is to decompose large or high-level requirements into a sufficient level of detail for implementation. Analysis also includes deriving functional requirements from the bits of a use case, a story, business rules, or other sources. Developers also write a lot of code to handle exceptions that could prevent successful execution. During analysis, identify potential error conditions, including user actions, system conditions, or data values that the system must detect and handle. As we move on, experienced BAs automatically scan for certain characteristics as they review requirements, a quality assessment. They should be correct, complete, feasible, necessary, unambiguous, and so on. We've all seen those lists, or sometimes acronyms. You'll never get perfect requirements, but keep these characteristics in mind as you write and review them. We also have to consider how someone could judge whether the requirement was correctly implemented and ready for use, its acceptance criteria. People also often make unstated assumptions regarding requirements. Conflicting and obsolete assumptions can cause problems later. Also, constraints. Constraints restrict the developer's design or implementation options. As we're thinking about constraints, confirm whether any constraints that are embedded in the requirements are truly restrictions or just solution ideas that somebody proposed. We also have business rules that often influence or serve as the source of specific pieces of functionality or data. It's important to know which rules apply to which processes, functions, and data objects. We'll come back to business rules later on. Additionally, products that pose safety risks must also include hazard analysis as part of their requirements analysis. We also want to think about the risk that any requirement could pose to the project's success. And finally, requirements reuse involves both crafting requirements that can be reused in other contexts and finding existing functionality that your application could exploit. Consider both reuse aspects during your analysis. And while we analyze individual requirements, other aspects of analysis assess sets of requirements. Specifically, we start with gaps because it's hard to see the requirements that aren't there. They're invisible. To assess completeness, we want to trace downward from business objectives through to the solution requirements to ensure that everything aligns properly. We also want to look for inconsistencies that can arise between a parent requirement and its children, or requirements of the same type that can conflict or be inconsistent. One requirement may say to do A and another says to do B, but it's logically impossible to do both. We also want to look for multiple instances of the same information. Karl once reviewed several use cases that had nearly, but not exactly, the same data structure definition in 3 different places. Well, in that case, the reader doesn't know which one to believe, if any. Replication also raises the risk of generating an inconsistency if one instance is changed, but the others are not. It's better to point to a single source of the information instead of duplicating it. We also have dependencies. Some requirements depend on others being implemented at the same time or previously. I find this one a lot in my work. For instance, it only makes sense to implement exception handling code concurrently with the functionality where the error could occur. And beyond the desirable characteristics of completeness and consistency that we mentioned earlier for individual requirements, we also want to make sure that groups of requirements are written and labeled in a way to be modifiable and traceable. We also want to create multiple representations of requirements using different thought processes, because that lets us compare them to find problems. Of course, earlier we mentioned the importance of prioritizing requirements, so we have to prioritize the set. And finally, stakeholders sometimes assume that the solution will include certain pieces of functionality without them having to say so explicitly. But as Karl likes to say, telepathy and clairvoyance are not very effective requirements elicitation tools. If you apply these analysis techniques, they will eventually become second nature to you, and they will make your requirements and requirement sets better. And with that, we will pass it back to Karl to talk about requirement specification.
Okay, I'm back. We just covered here a bunch of different analysis techniques. I think there's 18 all told on these 2 slides, and it's hard to remember all those. Eventually you will internalize them, but in the meantime, I find it really helpful to use checklists to remind me of things like this. So if you go to the website for this book at softwarerex.com, you can download checklists that will remind you of these kinds of things to look for during analysis, along with a bunch of other checklists as well. So there's a lot of useful aids there. The term requirement specification refers to 2 things, both to recording requirements knowledge in some form and to the deliverables you produce, such as a software requirements specification. And we see here on this slide, one of the very first business analysts in the world carefully writing a requirement specification. Actually, I'm pretty sure that's Charles Dickens, but close enough. Now, whenever you see the phrase writing requirements, I want you to mentally change that to representing requirements knowledge. We think of writing requirements in natural language text, and that, of course, is the most popular way to record requirements information because it's how people normally communicate. However, there are many alternative ways to represent knowledge, including tables, these visual models, tests, prototypes, mathematical expressions, all kinds of ways that you can communicate. Now, some people don't like to write requirements, but I think it's important to remember that the cost of recording knowledge is small compared to the cost of acquiring that knowledge or reacquiring it in the future. The hard part is not writing the requirements. The hard part is figuring out what they are. But human memories are imperfect and incomplete. They fade and distort over time, and also other people can't access them. So documented requirements constitute a kind of persistent group memory. We can record requirements in many structures, including documents, spreadsheets, requirements management tools, stickies on a wall, whatever works for you. These representations will vary in the information they contain, how the information is organized, how much detail is included, and so forth. So no matter what form you're using, just think of your requirements specification as just being a container for requirements related knowledge. Very important to remember that the goal of writing any kinds of requirements is always clear and effective communication. It's not purity of style, it's not conformance to the current fad or anything else. So keep this goal in mind. And there are many ways to achieve that. So two requirements specification practices that are fundamental are to write the requirements in consistent ways according to recognizable patterns, and to organize that information in a structured fashion with the help of a template. I'm going to talk in a moment about the importance of identifying and documenting business rules. And also, we're in the communication business here. Requirements are much more about communication than computing. So to facilitate that, each project should accumulate a glossary of significant terms, abbreviations, acronyms, and synonyms to make sure that everyone understands them in the same way. That will definitely help make our communication go a little bit more smoothly. So let me tell you a little story here. My friend Jeremy recently visited his local blood bank's website and made an appointment to donate blood later that day. Good for Jeremy. But when Jeremy arrived at the blood bank, the staff told him, well, we don't take same-day appointments, even though the website let him make that kind of appointment. And he was rather annoyed. Business rules are statements that define or restrict certain aspects of an organization's operations, or they influence the behaviors of people and systems within the organization. They're not software requirements themselves, but business rules often lead to derived requirements to enforce or comply with the rule. And as such, they're a critical piece of the requirements puzzle on every project. Well, the blood bank's website developers kind of dropped the ball on that issue by not enforcing in the software the no same day appointment policy. There are various sorts of business rules. Some simply state facts about the business. Many rules impose constraints on who can do what under what conditions. Action enablers trigger some system or business behavior, and computations, not surprisingly, describe how certain calculations are performed. Business rules can come from various sources. Company policies constitute a large source, like a store's policy for issuing refunds. Many systems need to comply with various laws and regulations. Industry standards, such as interface standards, are another major source. But too often, business rules are not documented at all, or they're embedded in the code. It's better to document business rules like you document requirements. They should be clear, complete, consistent, unambiguous, and so forth. So business rules are also subject to the same problems that can afflict requirements. One rule could conflict or overlap with another. Rules could be imprecise or fail to cover certain conditions. And as with the requirements, textual rules aren't always the best way to communicate information. Suppose you have an online store that offers various combinations of discounts and free shipping depending on the total price of an order and whether the customer is a club member. You could write out all those rules in natural language, but displaying them in the form of a decision table like this is easier to understand. The decision table shows all the various combinations of conditions and the resulting actions. Here we have two sets of conditions, depending on the range in which the order total falls, and whether or not the customer is a club member. And the various combinations of these lead to various actions down here, multiple possible actions. You might get a discount or you might not. You might get a discount of different amounts, and you might or might not get free shipping. So the table shows this very nicely. As an example, rule discount 5, these things need labels, states that if the order amount, the total is in the range of $50 to $100 inclusive, and the customer is a club member, then they get a 10% discount and they get free shipping. So representing the business logic with decision tables like this helps to avoid boundary value problems. You might have something below 50 and something above 50, but you don't know what happens at exactly 50. That's a problem. And it helps you avoid missing logical combinations. This compact table format is easier to create, read, and modify than a repetitive set of very similar rules, and it facilitates test design to ensure that we don't miss any condition combinations. So now we're going to have Candase pick up and talk about requirements validation.
Thanks, Karl. So by this point in the requirements development process, you've elicited requirements for some portion of the solution. You've analyzed them. You've recorded those requirements in appropriate forms. The team is now ready to begin development on that portion of the product, right? Maybe. Yes, you have some requirements, but how do you know that they're the right requirements? Are you confident that they'll meet the user's goals and address the business situation that led to launching the initiative in the first place? You could have a set of beautifully written and modeled requirements that appear to be crystal clear, complete, and unambiguous, and yet they could still be wrong. Requirements validation activities then confirm that some set of the requirements accurately describes the stakeholders' needs and that a solution based on these requirements would indeed satisfy those needs and achieve the intended business objectives. The terms verification and validation are often confused or misused. Verification confirms that whatever you've done was done correctly into specification, while validation ensures that you're doing the right thing. I come from a civil engineering background, and so when I think about bridges, validation is, did we design the bridge correctly? And verification is, well, was the bridge built to spec? So I love always to make those references back to my civil engineering days. As we think specifically about requirements validation, those validation activities are interwoven with the ongoing elicitation, analysis, and specification work. Sometimes prototypes or early releases of your solution, sometimes even delivering the full solution. Well, those are ways to validate with customers whether or not you're building the correct solution. But those can be expensive activities, especially if you're building the whole solution and you don't get much feedback until you've actually built something. So we have one core practice for ongoing requirements validation, and this involves reviewing requirements and testing them before you have any code whatsoever. So we're going to talk about this one practice, and we're going to start with review the requirements. In a peer review, when we peer review requirements, colleagues of the person who created the requirements artifact examine it for potential defects or other issues. And because of this, reviews are high leverage investment in quality, and the requirements reviews offer the highest leverage of all. Oh, I think I misspoke there. We need to choose the right review participants when we think about a requirements review. A BA might invite another analyst to review the requirements because the other BA, well, they know what kind of problems to look for. However, that other BA can't tell if the requirements properly address the business need. So to validate the requirements, you also need reviewers who supplied the information that led to those requirements, such as representatives of various user classes and the author of any higher level or predecessor system specification. Additionally, people who must base their work on the requirements, we like to call them victims of the requirements, also make good reviewers. Architects, designers, developers, and testers will all find different kinds of issues. Reviews also span a range of formality and rigor. The simplest involves just asking a colleague to look over something you've created. Well, that's an ad hoc review. In a pass around, a slightly deeper type of review, you invite several people to examine some requirements or diagrams. A team review and an inspection are more structured and more formal, which makes them slower and more expensive, but also more thorough and ultimately more valuable. Reviewers can use a checklist to remind them of common types of requirements problems to look for, like these: ambiguities, inconsistencies, duplications, omissions, unnecessary requirements, or even missing requirements. With experience, like most things, you'll internalize this list. However, we also have a checklist of this on the website, softwarerex.com. Once we've reviewed the requirements, we want to test the requirements, and we found out that you can begin testing your, quote, software as soon as you define your first requirement. Requirements describe what to build and how the solution should behave in various conditions. Tests describe how to tell if the solution is exhibiting the correct behavior and define situations where it does not. We find that writing tests from your mental image of how the system should behave is a completely different thought process than writing the requirements themselves. Once we have thought about how we would test the system, we can then walk through those tests and work them against the requirements to make sure that every test could be performed by firing off certain requirements. Every time we do that, we found missing requirements or erroneous requirements, sometimes missing or erroneous test cases. Additionally, agile teams often write acceptance criteria in the form of acceptance tests to define a user story's details. Those details help the developers understand what to implement and how to tell if they're done. The tests also help users envision whether a story will meet their needs, which is the essence of requirements validation. One popular way to write acceptance tests uses the given when then pattern. Think back to that user story we saw earlier. As an author, I want to view the statistics for my article so that I can see which topics my readers enjoy the most. Well, with that user story, this could be one acceptance test for that. Given what's our precondition, what's the state of the system or the user. So given I'm logged into the platform and I have published articles or articles published, when the trigger, the thing that says what the system should do, when I request to view the statistics, so that might be a link I click on, and then the actions that the system takes. Then a graph of my total article view statistics from the past 30 days is displayed, and a list of statistics, views, reads, and the like for individual articles is displayed in reverse chronological order by publication date. This compact way of writing these acceptance criteria and acceptance tests tells us how to test with the requirements done. It doesn't give us the exact details of how to implement it. The developer will figure that out. But we can say, if you can show us this, when I click this button and I see these things, well, we can accept that story is done. So it's an important way to validate our tests or validate our stories. Another thing we can do to test our requirements is to validate our requirements against various models and various tests. So suppose you've drawn a model to complement some of your textual requirements. You can then trace the logical execution path on the model with a highlighter pen as you walk through every test to see if the system would behave as expected. After you walk through all the highlighter paths, you look for problems. A path in the model that isn't highlighted, so a step that isn't used, could indicate that either we're missing a test or that the path does not reflect a legitimate system behavior. Conversely, if we have a test that has no corresponding path to trace in the model, well, either the test is invalid or the model is incomplete. Either way, that disconnect tells you there's a problem. Here's an example. I always like pictures. This is a portion of a process flow diagram for a website that lets sales representatives enter orders for a customer who's on the phone. In one scenario, the customer's requested items are all out of stock. And among many others, the tester has written the test case here. Well, given that the cart is empty, when the customer declines to order more items, then the process terminates. Now, if you attempt to trace the path this test describes on the process flow, you can't do it. The diagram says that if the requested items are not in stock and the customer doesn't want to order more items, thereby leaving the cart empty, the sales rep still sends an empty quote to the customer. That doesn't match the test. Assuming the test is correct, we found an error in the model and in any textual requirements that align with the model. And who wants to be sent an empty order? Armed with that knowledge about an error in the diagram, the BA can then redraw that portion of the process model to look like this. The blue diamond in this modified process now checks to see if the cart contains items following the end of the customer sales rep dialogue. If so, it sends the quote. If not, it terminates the process. Well, if we go back to that same test, now we can trace that test path correctly on the process flow, ending the sales process instead of sending the customer a meaningless quote with nothing in it. Finding errors like this one before the team writes the code and certainly before the customer encounters the problem is always a good thing. Customers are never in a good mood when they report a problem. Once we've analyzed, elicited, specified, and validated the requirements, we have to manage them. Requirements management is the subdomain of requirements engineering that deals with how requirements are used on the project and how the project responds to evolving needs. Requirements management involves several ongoing activities. First, you need to track versions of individual requirements as they change over time. Similarly, the status of each individual requirement changes over time. Each one goes from being proposed to approved to ultimately being either verified and correctly implemented in the product or deferred or deleted. And if you're serious about requirements management, you'll trace each one both backward to its origin and forward to design elements such as code and tests to show where it was implemented in the solution. Well, these are all valuable, but the two most important requirements management practices that apply to every project are establishing and managing requirements baselines. We'll talk more about this one in a minute, and managing changes to requirements effectively. You have to have mechanisms in place to add new requirements that come along, modify existing ones, and delete planned requirements from your backlog of pending work. Because as we all know, change happens. When we establish the requirements baseline, we think about the set of requirements that we've developed. So we have a set of requirements, we've confirmed that they describe a suitable solution. The next step is for the development team to be able to commit to implementing a subset of those requirements in a specific timeframe or development cycle. And that's a requirements baseline. It's an agreement. Establishing a baseline assures everyone that the team can move forward with development at a low risk of major changes. A sensible baselining and change approach ensures that everyone knows what they should, and sometimes more importantly, should not be working on. When we think about baselines, we can define a baseline in two ways. A time-bound baseline begins by establishing a time box. That could be a single iteration, a group of iterations, a planned release, or the entire product. This is often used in agile projects. The team then allocates the highest priority requirements from their backlog to the baseline until the time box's development and testing capacities are filled. Conversely, a scope-bound baseline consists of a logically grouped set of features, requirements, or stories that can be built, tested, approved, and deployed together as a unit. With the scope-bound approach, the requirements baseline is established without necessarily knowing its size or even when it will be delivered. A baseline serves as the reference point for commencing the change control process of those committed requirements. Your team should follow its defined requirements change process to make sure the right people make the right decisions. And this often involves negotiating changes in scope, time, and resources for the work. Baseline does not mean frozen. And with that, I believe I'm passing it back to Karl to close us out.
I'm back, yes. And nobody likes that last bullet here. They don't like the fact that if you change something, you're going to have to talk about what's going to change along with that. People want to keep stuffing as much as they can into the box, however you've defined the box, but you're still going to be done on time and it's still all going to be correct with no bugs, right? No, probably not. That's just the reality. I often point out that sometimes I'm not crazy about reality, but it's all I got, so I have to live with it. So thanks, Candase. We have covered a lot of ground quickly here today. I hope you've made some notes of practices that you feel would add value to your project, that might reduce risk, and might increase your chance of success. We can't promise that if you perform these 20 practices on your projects, you'll definitely be successful, but we can promise that you'll have fewer requirements-related headaches if you do. And that seems to me to be a strong enough motivation to look into them and see if these practices can help your teams beef up how they plan, develop, and manage their requirements. So with that, I think I'll come back on camera. I think we're all back.
Fantastic. Well, Karl, Candase, thank you so much for a really, really informative, fast-paced presentation with so much that you covered. I know from the comments in the chat that people are really, really appreciative. Just before we get on, we'll cover as many questions as we can. I just want to point out a couple of things before we get on to questions. The first is that the publishers have very, very kindly given us a 35% discount code off of Software Requirement Essentials using the code BLACKMetric. So if you go to informit.com/software requirements, you can access that. For those of you that opted into receiving emails after the session, I will also include that in the wrap-up email, so you don't need to write it down now. But before we get on to the questions, I want to tell you about how the competition will work. So in just a second, if you want to enter the competition, you might not want to, but if you're here by now, I think you probably do. I'm going to literally put a URL in, and all you need to do is put your name and email address in there. All this data is used for is running the competition. After the competition is run, it will be deleted. But this just lets us know who's here, who wants to actually enter with the chance of winning a copy of the book. So now in the chat, I'm going to put that link in, and in about 5 minutes time, we will draw it. So get typing your name and email in now. But whilst you are doing that, I am going to go through some of the questions. So our first question is from an anonymous attendee, but they mentioned Candase mentioned setting a decision rule. Could that be defined or explained a little more? So I wonder if you could just elaborate on what you mean by decision rule there, Candase.
No, sure, no worries. Yeah, so it's basically how you will make a decision. So this could be that it has to be a unanimous vote. Everybody agrees the same way. It could be consensus, that everybody, maybe they don't agree with it 100%, but they can live with it. Or it could be the decision maker or decision leader, the person who is coordinating those activities. Maybe they get to decide, or they can delegate. So all those are different types of decision rules.
Fantastic. So people are noticing that there's a message saying the competition's closed. That's because I've reused the form from a previous thing. Ignore that. As long as you've entered your details, it will get through. So that's with the competition. That's me repurposing an old form. Trust me, if you put your details in, it will get through to us. Michelle asks, is document analysis an elicitation technique? I think of it as more of an investigation technique. It might lead me to ask a question, but not contribute a requirement itself. What do we think to that one? Really quite thought-provoking question, that one.
Yeah, I think it's the answer to almost all of these questions is it depends on the situation. Okay, and that's not just a consultant's cop-out. It's just the reality is that things are situational. But yes, certainly document analysis can be important depending on what document you're reading and why you're reading it. You might find that this document has got a lot of business rules in it, which we maybe didn't know about otherwise, which could absolutely be an elicitation technique, because you have to then ask yourself, okay, do I have to build some functionality or set some data triggers or something up to enforce those business rules and comply with them? So I would say, yeah, it is an elicitation technique in the broad sense of we are looking for information. Some of that may turn into requirements. Some of it may turn into questions that we go ask the right people to get the knowledge, which may turn into requirements. And I think it's not important whether you call it an elicitation technique or not. You ask yourself, will this help us better understand the requirements and better communicate an understanding to design an appropriate solution? I think that's really the goal.
Definitely. Along a similar vein, John asks, regarding requirements elicitation, could you explain invention in this context? Because you mentioned that requirements can be elicited from various sources or invented. What do you mean in that context?
Well, I think back to an experience that I had on a project once, where I'm talking with a group of users, and if you are just asking, what do you want or what do you need to do, or what, some questions like that, even what tasks are you trying to perform, then those are going to be things that are already in people's minds. But suppose you asked a question like, would anybody ever need to do this? Or would it be helpful if you could do this thing and chain these things together and treat it as a single operation instead of multiple operations? In other words, you're inventing or suggesting a novel approach that no one had asked you for, no one had maybe thought of on their own. But you've got an idea as the business analyst. So that's what I mean by inventing requirements. Now, it's a very bad idea, I think, to just throw that in and build it simply because you thought of it. But I think it's a very good idea to be creative and come up with those ideas and throw them out there and have people say, oh, you could do that. That would save us a lot of time. I never thought of that. Or they might say, nope, no one ever need to do that. You don't know until you ask. That's what I mean by inventing requirements.
With visual models as well, it's an interesting psychological fact that people are just bad at coming up with stuff on the spot. But if you show them something, they can tell you what's wrong. And so having those draft or inventing what we call straw man models gives them something to poke holes at. I actually did a 1-hour talk internally at Argonne Digital called The Art and Science of Making Things Up. It was very well received.
Fantastic. Well, we are at the end of our allotted slot. We had so many questions. Karl, if people have a burning question, are you happy for them to connect with you on LinkedIn, or should they just read the book, or both?
Well, any of those are fine. I'm always happy to get emails from people. If you go to any of my websites, processimpact.com or karlwiegers.com, it's easy to reach me there, and feel free to send questions. I can't promise that I can answer everything, and I think you will find that there's an awful lot of information either in this book or in the Software Requirements 3rd edition book, or in another book I wrote called More About Software Requirements. Those I think will be very helpful for a lot of those kinds of questions. And there are certain kinds of questions that I don't answer. People sometimes say, well, what do you see the future of business analysis to be? Or what do you think about ChatGPT and business analysis? And I do not attempt to predict the future. Maybe Candase can do that. Maybe she has a crystal ball, but I don't try to predict the future. I'm not very good at it.
It's best avoided. I think. Well, Karl, Candase, thank you so much for such an informative session. Elisaveta, there's so many comments I've missed. Elisaveta says, thank you very much for one of the most informative hours in my life, which I think really
That's
shows
wonderful.
how well people have thought of this session. So for those of you, attending live, do give our presenters a virtual round of applause. And one of the ways that you can do that is, of course, to check out their book, check out the website, connect with them on social media. For those of you that have stayed till the very end, just a few community announcements before you log off. The first thing is, if you've liked this webinar, you will like other webinars that we run. I always try and get speakers on interesting topics and excellent speakers like Karl and Candase. And in little under a month's time, on the 1st of August, I have Lynn Gervin and Mick Bryan, who are talking about the art of backlog management. And it's an interactive Q&A. So slightly different format. We'll be having an open conversation, lots and lots of time for any issues, questions you have about backlogs. And there tend to be, backlogs can be quite problematic at times. I also wanted to just show you before I close, and this is again where I am, all of my windows are in the wrong place, but just in case you're not aware, there is a completely free quarterly PDF magazine called BA Digest. Now, BA Digest is written by practitioners for practitioners. You don't even have to register to download it. I mean, I hope you'll like it and you will choose to sign up, but you can just go to our website and download it, or you can read it online. And to give you an insight of what it looks like this. We've got over 60 pages every quarter of really practical practitioner-led content. So if you are interested in accessing that, the quick way of accessing it is badigest.link. That's badigest.link, and you'll always find the most recent version there. It's a labour of love, this magazine, I can tell you. But we are a couple of moments over, which I always hate doing. So again, thank you everyone for tuning in live. I know we've had a really global representation today. Karl, Candase, thank you for such a stunning presentation. Have a fantastic evening, afternoon, morning, everyone, and hope to catch up with you all again soon. So take care and bye for now.
Thanks, Adrian. Thanks, everybody. Bye-bye.
Bye for now.
Bye. Bye.